This lesson is classifying triangles. Lesson 4.1. Items you will need: pencil and paper, a calculator, and to read the Gospel of John, chapter 11, verse 26. Let's do the warm-up. Classify each angle as acute, obtuse, or right. And number 4, if the perimeter is 47, find x and the lengths of the three sides. Go ahead and pause the video now. Number 1 is a right angle, 2 is acute, 3 is obtuse. In number 4, x should be 5, and the sides are 8, 16, and 23. Objectives. We're going to classify triangles by their angle measures and their side lengths. We're also going to use triangle classification to find angle measures and side lengths. New vocabulary terms: acute triangle, equiangular triangle, right triangle, obtuse triangle, equilateral triangle, isosceles triangle, and scalene triangle. Recall that a triangle is a polygon with three sides. Triangles can be classified in two ways: by their angle measures or by their side lengths. The first one we have here is classified by looking at just the angles. The second one is by looking at the sides. Now, to classify is to give an object, a thing, or an idea its correct name or category. So we look at the following triangle. We see that two sides are congruent and one side is unlike the other two. Now, we know that this triangle fits into an isosceles classification. Isosceles means that at least two sides are congruent. But we also know that the classification fits for acute triangles because all the angles in the triangle are less than 90. This circle represents the family of all possible isosceles triangles. This circle represents the family of all acute triangles, and notice that they overlap. So the triangle that we're looking at falls in the overlap of the two families. This triangle has two distinct classifications. It's isosceles, but it's also acute at the same time. A, B, and C are called the vertices. The triangle has three sides: side AB, side BC, and side AC. The triangle also has three angles: angle CBA, angle BAC, and angle ACB. Each of the points A, B, and C represent what's called a vertex. The plural of vertex is vertices. Here's how we classify triangles by their angle measures. The first is an acute triangle, where all angles are less than 90 degrees. The second is called equiangular, where all angles are 60 degrees. The third one is a right triangle, where one right angle is 90 degrees. The last one is called an obtuse triangle, where one angle is obtuse, or greater than 90, but less than 180. Classify triangle BDC, triangle ADC, and triangle ABD by their angle measures. Well, we know that the measure of angle DBC is 100 degrees. So that puts triangle BDC in the obtuse triangle family. We know that the measure of angle ADC is 90 degrees from the picture. So this means that triangle ADC is in the right triangle family. We know that the measure of angle ADB is 20 degrees, and the measure of angle DAB is 80 degrees. Next, Angle ABD and angle DBC form a linear pair. And by the linear pair theorem, this means that the measure of angle ABD must be 80 degrees, since a linear pair angles have to be supplementary. Since all angles in triangle ABD are acute, this triangle is in the acute family. All right, you try it on your own. Go ahead and classify triangle FHG by its angle measures. Go ahead and pause the video now. Since triangle GHE is a right triangle, and using the angle addition postulate, we get that 90 is equal to 30 plus the measure of angle FHG. This implies that angle FHG is 60 by the subtraction property of equality. Now, since all the angles in triangle FHG are 60, this means that triangle FHG is in the equiangular triangle family. This is how we classify triangles by their sides. We have three classifications. Number one, isosceles, where at least two sides are congruent. Equilateral, where all sides are congruent. And scalene, where no sides are congruent. Now here's the weird thing. Since an isosceles means at least two sides are congruent, that means that an equilateral triangle is also isosceles, because all three sides are congruent, and that means 3 is greater than or equal to 2, and that's what at least 2 means. But we never really call an equilateral triangle an isosceles triangle. We just say it's equilateral. Remember, when you look at a figure, you cannot assume segments are congruent based on the appearance. They must be marked as congruent. Example 2a, classifying triangles by side lengths. Let's go ahead and classify triangle EHF by its side lengths. From the figure, we can see that segment EF is congruent to segment HF. So we know the measure of HF is 10. And triangle EHF is isosceles. Let's classify triangle EHG by its side lengths. By the segment addition postulate, we know that segment EG can be rewritten as EF plus FG. Well, by substitution property, that's 10 plus 4, which is 14. Now, since no sides are congruent, triangle EHG is scalene. Scalene. All right, check it out for yourself. Go ahead and classify triangle ACD by its side lengths. Pause the video now. From the figure, we can see that segment AB is congruent to segment AC. So AC is 15 in measure. And so this means triangle ACD is scalene. Finding the side lengths. So we're going to find the side lengths of triangle JKL. Now from the picture, we can see that JK is congruent in measure to KL. This means that the measure of JK is equal to the measure of KL. So by the substitution property, we can replace those with their expressions, and then we solve for x using algebra. Now we're going to substitute 8.5 back into the problem to find all three sides. And we see, since two sides are equal in measure, 23.3 for JK and KL, this is an isosceles triangle. And we found the side lengths. All right, you try it on your own. Go ahead and find the side lengths of an equilateral triangle, triangle FGH. Pause the video now. Find the value of y. We know that all sides are equal in length, so FG is congruent to GH is congruent to FH. That's given. So the measures are all equal. That's the definition of congruent segments. So we really only need to set two expressions equal to each other. So I choose 3y minus 4 is equal to 2y plus 3. Substitution property of equality. Solve for y. Substitute the y back in. We only really need to put it back into one expression since all sides are equal, and we get 17. It is only necessary to substitute 7 into one expression. Again, we knew from the given that it was an equilateral triangle. However, I would say it's good to check 7 into all of them just in case you want to check your algebra to see if you're doing your algebra correctly. A steel mill produces roof supports by welding pieces of steel beams into equilateral triangles. Each side of the triangle is 18 feet long. How many triangles can be formed from 420 feet of steel beam? Well, the amount of steel needed to make one triangle is equal to the perimeter P of the equilateral triangle. Since all sides are the same, we only have to take 3 times 18, and we get 54 feet is the perimeter of one triangle. Now let's find out how many times 54 feet will divide into 420. When I take 54 and divide it into 420, I get 7.7 repeating, so about 7 times. There's not enough steel to make 8 triangles, so 7 triangles can be made from the 420 feet. All right, you go ahead and try this on your own. Go ahead and pause the video now. The perimeter of one triangle fence will be 4 plus 4 plus 5, which is 13 feet. We're going to see how many times 13 goes into 100, and that's about 7.69 times. David can only make 7 of these fences. He needs to get more material to finish the project. All right, here's the lesson quiz. Go ahead and pause the video now and see if you can answer these questions. Number 1 is both acute and equilateral. Number 2 is obtuse and scalene. Number 3 is acute and scalene. Number 4, the side lengths are 29, 29, and 23.